capillary beds or sinuses of the lobules, and then gets brought back to the general circulation. So here's some photos of hepatic lobules. One from a slide. All these holes are vessels and ducts. This one right in the middle would be a central vein. Here's an illustration where you can see more of sinusoids. We've got portal vein branch, hepatic artery branch, bile ductule. And this shows more specifically where things would be in just one section of a lobule. So we've got the bile canaliculi all around the hepatocytes. The sinusoids are above and below and branched a lot. So one thing that's not shown on here is the Kupffer cells. They would mostly be in the sinusoids. Questions on microscopic structure of the liver? Liver functions go well beyond just digestion, but they're very general, and that's why we just classify it as a digestive organ. It's going to store glycogen and release it as glucose when the body needs it. If you remember, muscles also store glycogen, but they just have it for themselves. The liver stores it for everyone. Liver synthesizes several things, including some lipids like cholesterol and all the plasma proteins except immunoglobulins, because those are made by B cells. Stores some other things like iron and vitamins that can be stored, which includes A, D, and B12. Some vitamins can't be stored. They're just excreted if you have some you're not using. Phagocytosis, that's done by the Kupffer cells to clean up pathogens or damaged red blood cells. And that's one of the reasons you can live without a spleen, is the liver takes up some of those functions anyway. Detoxifying alcohol and drugs, and then secreting bile, and that's the digestive function. Bile is a liquid, so it's mostly water. The active ingredient for digestion is the bile salts. Those are derived from cholesterol. Bile pigments are also found in it, and those are mostly there to be excreted in the feces. That includes bilirubin from red blood cell breakdown. There's also some cholesterol, either to be excreted or because it just slipped through with the bile salts because they're built together, and electrolytes. Bile helps with fat digestion, but it's not an enzyme. It's not going to actually break anything down into smaller molecules. What it does is called emulsification. It's part hydrophilic, part hydrophobic, and that means it can make water and fat talk to each other. Can anyone think of other molecules that are like that? Yeah, phospholipids, they use that property to put the lipids together as a barrier and talk to the body fluids inside and out. How about one that you probably have already used today? Probably used it on your hands if you went to the bathroom. Soap. Soap is an emulsifier. It lets the grease, the oils on your hands or the grease on your dishes stick to the water so you can wash it off. So what the emulsifiers do for fat digestion is they break the globs into smaller globs. So they don't actually break up any of the fat molecules, but you put a bunch of hydrophobic things into water and they're going to cluster together. You get too big a glob, the enzymes are trying to get at it from the outside and they're going to be working their way in very slowly. The bile breaks it into smaller globs so that more of the enzyme can get at it at once. Questions on bile? That takes us to the gallbladder. Its job is to store and concentrate bile. So as it sits in there, some of the water gets reabsorbed from it. And then when it's needed, because you've had a fatty meal, there's fat in your intestine, the gallbladder contracts and pushes the bile back out. This tube here that connects to the gallbladder is the cystic duct. And that's a two-way street. When the bile comes out of the liver, it goes out into the gallbladder. And then when the gallbladder contracts, the bile comes back and into this tube, which is the common bile duct. Common because it joins liver and gallbladder. Anybody not have a gallbladder? Do you have any problems because of it?
Here and there. Had to get a stent put in because when they took mine off, they forgot to take my bile out.
Oops.
Oh my God, it's the most painful thing ever.
Yeah, so sometimes, a lot of times, there's just no effects from it. Some people do have trouble if they eat a lot of fat at once of getting indigestion because it takes longer to break it down. All right, that brings us back to the alimentary canal in the small intestine. The small intestine is going to complete the digestion and do the majority of the absorption. Once the food leaves the stomach and it's been combined with gastric juice and partially broken down, it's called chyme. So, small intestine is going to digest chyme. 3 regions of the small intestine are the duodenum, sometimes pronounced duodenum, jejunum, pretend you're talking about summer and stuttering, jejunum, okay, and ileum. So, sounds the same as the hip bones, but it has an E in it. On here, the duodenum is this first loop, the part that surrounds the pancreas. And then the rest of this, part of it's hidden. You get jejunum first, and then ileum. And there's not really an obvious change point from the outside. You've got this notch to tell you when you go from duodenum to jejunum. You can tell this is ileum because it's the end where it connects to the large intestine. But anywhere in the middle, you just kind of estimate. Now, at the microscopic level, if you look at the walls, you can tell the difference. And we have all 3 regions in lab on our slides. So the duodenum is where the secretions from the pancreas and liver enter. It goes from the pyloric sphincter to a little bend inferior to the stomach. It's about 10 inches long or 25 centimeters. The name duodenum means 12. I'm not sure if that meant it was 12 finger widths long when they were first studying it, or after death in the cadavers it kind of relaxed and extended a little bit. The jejunum and ileum are within the peritoneal cavity, so their serosa is visceral peritoneum. There's no obvious division between them on the outside, as I said. They're both much longer than the duodenum, and the ileum is the longest. So the jejunum is between 2 and 2.5 meters. It's a little bit larger in diameter. On the inside it has more surface area because it does major digesting and absorbing. The ileum is 3 to 3.5 meters long. Now, for those who don't think in metric, a 6-foot tall man is 1.8 meters. So your intestines are several times longer than you are tall. What distinguishes the ileum is that it has Peyer's patches in the mucosa, lymphatic nodules. And you'll see those as purple clusters on the slides, and they're in the lamina propria. The end of the ileum is the ileocecal sphincter. Membranes in the abdominal cavity. We talked about the peritoneum. The visceral peritoneum forms the serosa of the jejunum and ileum, also part of the large intestine. Mesentery is a fold of peritoneum that connects from that serosa to the parietal peritoneum around it and helps hold the small intestine in place. Okay? And it's just holding them at the back, so there's still some shift, but it keeps them from all slumping down. Another membrane is the greater omentum. This is a pouch that comes down from the stomach and then folds and comes back up, and that can store some fat to help pad the abdominal organs. Here's how you can tell whether that fat is in your greater omentum or subcutaneous. Usually for men, it's more in the greater omentum, and that's why they can suck in their guts, because the greater omentum is inside your abdominal muscles. But if you suck in and you still have this little paunch here, then it's subcutaneous rather than in the greater omentum.
You don't have any
So here's what they look like. This is a illustration from the front where you can see the greater omentum in front of the intestines. Okay. On the cadaver, which we'll look at in lab, they've kind of crumpled it up at the top so you can still see the small intestines, but part of it is there. On this side view, this loop is the greater omentum, and then all of these that come out and loop around these tubes, which are small intestine, are parts of the mesentery. Any questions on the membranes? In the mucosa of the small intestine, we need a lot of surface area for nutrients to touch and get absorbed. There's 3 levels of increasing the surface area. The first one is actually formed by the submucosa. It makes a bunch of folds that go around the diameter of the intestine. They're called plicae circularis. Now, there are some sources that just call them circular folds, but our book isn't one of them. So that's submucosa. The mucosa will follow all along that, and it has additional bumps. I'll just do 1 plica's worth. Those are called villi. Singular is villus. So if you watch the Body Machine, I think I didn't show it last week, but it was going on the Kahoot. They say down through the villi, which look a little silli, and it showed the little fingers waving in the small intestine. If you zoom in on a villus, you'll see the epithelium and the cells have their own villi. Those are microvilli. So, the plicae circularis and the villi are kind of like if you lumped a carpet to make ridges. And then all the little fibers of the carpet would be the villi. So here's the more careful illustration of, you can see what the plicae look like behind. Here's what they look like in cross-section. And then this darker orange is all mucosa, and each one of those bumps is a villus. And they put in a little bit of shading where you can see them coming away, see that they're bumps, not continuing ridges. In addition to the epithelium with microvilli, on the inside of each villus is a lymphatic capillary called a lacteal, and a network of blood capillaries. I'll just do those in red.